Hi Calculus student, this video is for chapter 3.5, derivatives of trig functions. So we learn how to do derivative of x to the n using power rule. So we can do derivative of polynomials. We can also do derivative of rational function using quotient rule and product rule. So we are moving on to find derivative of trig functions. So namely sine, cosine, tangent, cotangent, secant, cosecant, these 6 trig functions. The basic one is sine x. So if you do a derivative of sine x, the rule said that it's equal to cosine x. But how? Okay, so I'm going to show you a book from James Stewart. That shows us how to prove that using limit definition, the derivative of sine x will become cosine x. Okay, so in our free book, they kind of use the graphical approach where they would draw the derivative of sine x, and it looked like it's a cosine x, but it's not as vigorous as using the limit definition. So let's see, this definition of a derivative function is f of x plus h minus f of x over h when h approaches 0, right? So in our case, our function is sine x plus h. So we'll write sine x plus h minus sine x over h. This is the real definition of a finding the derivative of sine x. And then you would expand it, the sine x plus h out. If you do direct substitution, it's 0 over 0. That means you can factor or replace it with another limit. So what we do is we replace it with a sum formula of sine. So remember when you do trigonometry or pre-calc, in sine a plus b is actually sine a cosine b plus cosine a sine b. So we rewrite sine x plus h is sine x cosine h plus cosine x sine h minus sine x all over h. And then we'll group these two terms together because these two terms has sine x as the common factor. So we have sine x cosine h minus sine x over h. And then the second one is cosine x sine h over h. Now this one is really good, the second one, because you can just write sine h over h, which we remember if you do a limit of h approaches 0, sine h over h, remember this one that we proved, that's equal to 1, right? So in our case, we use the term x, but it's the same. So this become 1. So our problem is with cosine h minus 1 over h. What would this equal to? So we'll do the limits like one by one. So do the limit of sine x, do the limit of this, do the limit of cosine x, do the limit of this. This one we know is 1. Let's move down a little bit. So we know that this one is 1. The limit h approaches 0, cosine x is just cosine x because there's no h involved, right? It turns out that the sine x, h approaches 0 will be 0, right? You can just plug it in. But we're not sure if cosine h minus 1 over h is a constant, because if it go to infinity, it might not work. So so this is how later on, so they prove the sine x over h. Later on, they prove that, okay, so this is the limit cosine theta minus 1 over theta. This, in our case, is h. And they use, I think I did that in class. They do the conjugate of cosine x minus 1, cosine x theta plus 1. And so you would have sine theta over theta again. It turns out that this particular limit is 0. So all in all, it's very long. You can say that the derivative function of sine x, after you do all the plug-in, would equal to 0 times 1. Is it 1? Yeah. Plus cosine x times 1, and then all this becomes 0. This one becomes, the first one becomes 0. So f prime of x is cosine x. So this is the real proof using sum and difference. So and then all the other ones, so when you do cosine x, you can do the similar things. If you're interested, you can go online and look. There is a lot of proofs, real proofs on how to do this. Then for tangent x, you will use quotient rule because tangent is sine over cosine. So all these are the results of actually laboriously do limit x approach 0 for the function. So now you need to memorize this. Well, in the online class, you don't need to memorize, but you need to know where you can find this formula. So whenever you want to do a derivative of sine x, it would be cosine x. If you are doing a derivative of cosine x, it will be negative sine x. If you do a derivative of tangent x, that would be secant square x. So it can be proved. If I have time during class, I'll prove it. And then the derivative of cotangent is negative cosecant x. Okay. Then for secant x, if you do a derivative of it, is secant tangent. So it seems like you add more in the derivative. You would get your secant x and then multiply by the tangent x. And then for cosecant x is for cosecant x is negative cosecant x cotangent x. So now after we look at all these rules, so let's do derivative of these. First, find a derivative of f of x if it is x cubed minus sine x plus cosine x. So choose the pen first. So to do a derivative, we'll say f prime of x is equal to d dx of each one. X cubed, I'll use power rule minus d dx of sine x plus the derivative or can apply the differential rule of cosine x to it. So for still remember the power rule, it will be 3x squared for the first term. This one, we remember it was cosine x. After you apply the derivative rule, the differentiation rule, and then for cosine x is negative sine x. And that is the derivative of f of x. The second one, derivative of x tangent x. Did you recognize that this is a product? The first is x, the second is tangent x. So I'll use the fake and GIF things. F is equal to x. G is equal to tangent x. F prime is equal to 1. G prime, do you remember what tangent x derivative is? Tangent x is secant square x. So tangent and secant are very related in derivative. So secant square x. Now we're ready to do the f prime. So we'll say f prime of x is equal to fake plus GIF. So fake is 1 times tangent x, so 1 times tangent x plus GIF is secant square x times x. And that is our derivative. Some people like to simplify secant square as 1 plus tangent square so that this particular expression has only tangent square. So you can see in some case they would just expand this out, but it is, I don't know how open math tackle this. So you can say the final answer or the alternative answer for this is sometimes when you see the answer key it looks funny is because you have trig identity. Okay, so you can alternative answer would be that. C, I would say try this. So we'll do this in class. Did you notice that it is quotient rule? Okay, this is F and G, so you should try it first. Okay, so let's go to the second page of 3.5. So we have this find dy dx for y equal to sine x tangent x. This is again a product rule. So we'll do, but both of them are, trig functions. So it's a little different from the last one that we did of a product rule. Make it a little bigger first. Okay, so sine x plus tangent x. So make more space. We would say we need to do select the pen first. So we'll say this is a product. So this is a function. This is a function multiplying. So the derivative would be fig and GIF f equal to sine x G equal to tangent x. So remember f prime is cosine x, positive. G prime is, do you remember tangent is secant square x. So now we do dy dx now. So d dx of sine x tangent x will equal to fix and GIF, right? Fig plus GIF. Fig is cosine x times tangent x plus sine x times secant square x. So you could stop here because that is the answer. But usually when you check answer, this it doesn't look like this. If you look at this, they have 1, 2, 3, 4, 4 different trig functions. Let's simplify it. Cosine x is cosine x. Tangent can be written as sine x cosine x, right? You can see that we can cancel this, right? And then sine x is sine x. What is secant? Secant is 1 over cosine, so we can say cosine square x. So both of them has sine x. Do you notice that? So you can write it as sine x, factor out 1 plus secant square x, or 1 plus, I think either way is fine. You can either do secant square x, or you can do 1 over cosine x. Just simplify it as much as possible. 1 plus secant square x is not any particular identity. So secant square x is related to tangent x, but that's too much. So the best you can do right now is to simplify like this. So this another one is f of x equal to sine x over x, find dy dx, or find f prime. So I'll do it in class. So it's a quotient rule. So you can try it first also. The second one that we want to do is higher derivative. So sometimes if sine or cosine is used to model some motion, the second derivative is an acceleration. So we want to find the first and the second. Okay, so y prime, so dy dx, first, right? Would equal to d of dx, x minus d of dx, half sine x. So d dx of x is 1 half d of 1 half sine x is 1 half cosine x. Right, so that is the first derivative. What is d square y d square dx square? D square over dx of so that is the derivative of the first one of 1 minus 1 half cosine x, right? So we'll do the derivative of 1, which is 0. And we'll do a derivative of negative 1 half cosine x, which is negative 1 half times negative sine x. When you do a derivative of cosine, it's negative sine. So it's become negative, negative, positive, positive sine x. And that is the second derivative. Okay. So I'm going to stop here and we'll do the second part of 3.5 in the next video.